Man, that Newcomb lunch was really good today.
Yeah, I don't think you really should have grabbed that onion.
Yeah, the onion did not look that good.
No, it was the perfect onion out of the whole bunch. No way it's bad.
You're not gonna eat that, are you?
No, I'll prove it right now.
Looks very spotty to me. I don't know if that's healthy to eat.
Yeah, it looks awful.
Hey, Newcomb wouldn't do me one like that. I'll show it to you.
Okay. Oh my god. Is she alright?
Yeah, I don't think so. Looks like she made a bad decision.
Oh.
Darnell, I wonder how we can prevent something like this in the future.
Yeah, if only there was some way to tell if some produce was spoiled or not.
Yeah, some way that is more accurate than just our own eyes.
Cases like this are actually not that uncommon. In fact, last year alone, Virginia experienced a statewide salmonella outbreak from onions. So it's better to be selective and be safe.
Man, I feel so bad for Victoria. She got sick at a time where we need to finish this project for ML, and apparently other people have also been experiencing the same problem. Maybe there's something from this class that we could use to apply to this situation, so that others are less likely to experience food poisoning. Food poisoning problem. Oh, what's this? A data set? Fresh and still images of fruits and vegetables. I see. Maybe we can create a model to take in an image and determine whether that produce is fresh or stale. That sounds interesting.
So the images in the Kaggle dataset are 512 by 512. These are huge images, and really not all models need this. In fact, some models, such as the AlexNet, run better on smaller images. So what we did was we took this original image and resized it to 224 by 224. This is the optimal size, coincidentally, for a teachable machine. Next, after we resized all the images, we then had pretty much like thousands and thousands of images. However, once again, a model doesn't really need all of these images in order to train, and given our GPU space, this was kind of a slow process. So instead, we truncated our folders and selected only around 200 images for each folder. This in turn may have impacted accuracy, but we think the speed improvement was worth it. After we've cleaned and processed the data, it's now time to input into a training model. For this, we've used 10 epochs with a batch size of 16 and a learning rate of 0.005. The resulting model here, as we can see, is when I hold an orange, it is a fresh orange. There's also the option to upload an image file instead as well.
Even though our model worked really well, we have to admit that it did have two significant limitations. For one, it could not handle pictures that are not of the 6 different types of produce we accounted for, things like a human face or a picture of a car. Secondly, even though the model achieved near 100% accuracy in most classes, some classes like bell peppers stood significantly lower at 84% accuracy, which we couldn't do much about because our model's architecture was too simple to tweak the individual things to the better. To solve this, we developed the idea for a more complex convoluted neural network, which we chose to professionally call Produce Evaluator V1. This network will be made of 7 different models. One multi-class classification model that would determine what produce a given input is. This is regardless of the freshness or staleness of this produce. This model will then send the input to the appropriate binary classification model that determines if the specific produce is stale or fresh. If the model does not judge the input to be any type of produce above a certain confidence threshold, we can then say that it's an unrelated picture. Because we have 7 different models, we have control over more hyperparameters, so we can individually tweak many of them to make sure that every produce gets predicted with high enough accuracy. Vicky, it's so good to have you here, especially after your twin tragically passed away from fruit complications a month ago. I really hope that doesn't happen again.
Yeah, so sorry that happened.
Yeah, she's always been really reckless, you know, so this is kind of not a surprise.
Speaking of reckless, are you about to eat this without checking if it's spoiled or not?
I'm not sure if it's like spoiled or not. But yeah, let me check.
Oh, what do you got there?
Oh, this is just a machine learning model that can accurately predict whether something is fresh or stale. And let's
Fancy.
see. Oh, this is good to eat.
Oh, perfect.
Let's share.